Hey there, so I have a couple of problems from section 8.1. I know this section can be a struggle for students because you have to be able to apply all of your factoring techniques, and some of the problems can be a real booger. For example, this one, we've got negative 16x squared plus 9 divided by 4x squared plus 5x minus 6. Now the idea is to factor both the numerator and the denominator. Whenever you have a negative in the numerator as your leading coefficient, or a negative period as your leading coefficient, your strategy needs to be a little different. There's a couple of things we can do. We can factor out that negative. That may be the best route to take. You could also switch this around. You could write it as 9 minus 16x squared. But I think for this problem, the best thing to do is factor out a negative. So it's like there's a negative 1 coming out front. And that's going to change that negative 16x squared to positive 16x squared, and that plus 9 to minus 9 divided by, now this denominator is ready to factor. I'm going to go ahead and recopy it as is, and we'll factor in the next step. Okay, so all I did was factor out a negative 1, which is going to change both of those signs. So the next step, what I notice is in the numerator, we have a difference of squares. So what do I mean by that? So the 16x squared is a perfect square because the square root of that is 4x. Notice I took the square root of each part. And then the square root of 9 is 3. And whenever you have a perfect square for your first term, a perfect square for your second term, and subtraction, you're going to factor this into two binomials with one plus in between and one minus. And again, we mentioned the square root of 16x squared is 4x. Goes in the first position in each of these factors. And then the square root of 9 is 3, which goes in the second position of each of those factors. Now let's work on factoring the denominator. Okay, now over here I'm going to do some scratch work. There is no greatest common factor for this trinomial. There's nothing numerically. 4, 5, and 6, they don't have any factors in common. X squared, x, and no x at all has no factors in common as well. This is what we call the AC method. You could also factor this by trial and error, but I like the AC method because it's a method that works every time. So I'm trying to find numbers that multiply to be 4 times negative 6. Well, we know 4 times negative 6 is negative 24. So multiplies to be negative 24 and adds to be the middle coefficient, which is 5. And numbers that multiply to be negative 24 and add to be positive 5, that's a positive 8 and a negative 3. Now 24 has lots of factors. 1 times 24, 2 times 12, 3 times 8, and then there we are with the 3 times 8. Remember, anytime you multiply to be a negative, one number's positive, one's negative. The larger one matches the sign of the middle number, matches the 5. So that's why I made it positive 8 instead of negative 8. Now what do? I rewrite my problem replacing the 5x with 8x minus 3x. So watch this. I got 4x squared plus 8x minus 3x and then minus 6. So the first and last terms stay where they are. The middle is replaced with 8x minus 3x, which is equivalent to 5x. Now next step is factor by grouping. I pull out this greatest common factor of 4x. That leaves x plus 2. They have a greatest common factor of negative 3, which also leaves x plus 2. Those parentheses must match. So I pull out the matching x plus 2 times 4x minus 3. Now again, we could get there without the AC method, but it's tried and true. So I'm going to write x plus 2 times 4x minus 3. Now, once you get your numerator and denominator completely factored, then it's time to cancel common factors. So if you will notice, this 4x minus 3 cancels this 4x minus 3. You cannot cancel anything unless it's a factor. So for example, I got an x squared and an x squared. Can I cancel those here? No, because this is not factored in the numerator and denominator. It has to be a product instead of addition and subtraction. So 4x minus 3 cancels with 4x minus 3. That leaves me with negative out front, 4x plus 3 over x plus 2. That is an appropriate answer. Also, this negative, remember that's really a negative 1. I didn't write the 1, but negative or negative 1 means the same thing. You could distribute that inside So it would be negative 4x minus 3 over x plus 2. Notice it goes inside just the numerator, not in the denominator as well, because it's like it's negative 1 over a positive 1. So this is also a correct answer. So again, negative, I wrote on the first original correct answer, so I want to be clear. Negative out front, or distribute the negative inside. And Newton-Alta should give you credit for both of those. Now let's do another problem. So for our second quick example of simplifying rational expressions, so again, the temptation is to want to cancel 16, 16, u to the third with u squared. You can't do that because of the addition and subtraction. So you never can cancel part of addition and subtraction. So the goal is to factor. Now in the numerator, what we have here is a sum of cubes. 16u to the third is a perfect cube, and 8 is a perfect cube. And perfect cubes factor into a short set of parentheses, which represents a binomial, and then a long set of parentheses, which is going to be a trinomial. And in the denominator, we'll talk about it when we get there, but let's factor this numerator. So what happens is when you have a sum addition of cubes, you take the cubed root of the first position. So the cubed root of 16 is 2. You know why? Because 2 times 2 times... No, it's not. Let's try this again. There's a greatest common factor there. I'm not paying attention to that. Let me back up. I know I should edit it and start back over, but it's worth hearing the thinking process, right? There's a greatest common factor here. Always pull that out first. So I'm going to erase my line and make it shorter. Let's pull out the greatest common factor of 8, right? And that leaves 2u to the third plus 1. Okay. Now in the denominator, I have a greatest common factor of 4. And when I pull that out, that's going to be 4u squared minus 1. Now what happens here, this one's frustrating. I can see why this would be a question. 4 goes into 8 2 times. Okay, so here those cancel and leave a 2. So I have 2 times 2u to the third plus 1 divided by 4u squared minus 1. Now the 4u squared minus 1 factors, but the 2u to the third plus 1 does not factor further. So I wish that 2 wasn't there, and then that would be a sum of cubes. But since it's there, I can't factor this any further. Now the denominator, in case you want to see, would factor into 2u plus 1 times 2u minus 1. But again, that's not going to... My 2u to the third plus 1 in the numerator doesn't factor, so this is a completely simplified rational expression. If that 2 weren't there, we could factor this further, but it still wouldn't cancel with 2u plus 1 and 2u minus 1. So I think this is just kind of a tricky problem, and all you can factor out is the greatest common factor and cancel those, and that's it. That's all we can do. So back up to here is your final answer. We tried to go further, but with the 2 there, this is not a sum of cubes. And down here is a difference of squares, which we factor, but it won't cancel with any of the factors in the numerator. So that's it. I hope this helps you out. Have a wonderful day. Hey, let me point out one more thing. This final answer here also could be written as 4u to the third plus 2. In other words, distribute that 2 back inside over 4u squared minus 1. This will be a correct answer as well. I really like the top one. There's no point, there's no reason you should distribute that 2 back inside. But I was just going to let you know, if you saw that as a correct answer, that's why they distributed it back inside. There's no requirement that you should do that. The factored version is just fine. Now I hope you have a great day.